Hello and welcome to this lesson. We are going to look at the integration by parts. So, integration by parts. Generally today I just want to look at the integration of exponential ax cos bx, of which you can go and check also the integration of exponential ax sin bx. So let me use today, you know very well that integration by parts we use u dv minus integral of v du. This formula generally is what I want to use, but I want to use it in a different way, that is the DI method. So I choose one to be differentiated, one to be integrated. And from this, what is to be integrated and which one to be differentiated? Using Elate method, so I have Elate, that is the inverse function, the logarithmic function. Then we have the trigonometric function, we have the exponential function. If you look at our case here, we have the exponential function and the trigonometric function. So I choose the trigonometric function to be differentiated, that is our u. Then I take the exponential function to be integrated. So considering these signs, don't worry, this one is just an improvised formula. That is where you can see u dv minus v du. So this sign here is what we have. That is why we have plus, minus, plus. So if I differentiate cos bx, that means I'll be having negative b sine bx. Then if I integrate exponential ax, I'll be having 1 over exponential ax. You can see this one, I'll be doing this, cross multiply u dv. And also this one is v du, is my integral part. If you look at this one, it's not the same as the function we have here. It means I proceed to another step, which I'll be having. This one will be negative b squared cos bx. This one will be 1 over a squared exponential ax. So if I have that, you can see now, I'll be multiplying. This one is u dv. I have another u dv, then v du becomes my integral part. You can see is almost the same as the function we had initially. That is the function we are given. So we are through to go. We can't proceed to another step. Let's stop there. So the next thing, let me multiply. It means now the integral. It means the integral of exponential ax cos bx is equals to, let me multiply u dv. This one is, I have 1 over a exponential ax cos bx plus, so plus, because this sign negative times negative is positive, then I multiply by this. I'll be having now b over a squared exponential ax sine bx, then plus the integral. Will it? No, not really plus, because I have this one, plus times minus is negative. I multiply, so it's like now I have minus b squared over a squared, b squared over a squared exponential ax cos bx. But not just that one, we have the integral, because that is the integral part. So if I have that part, now it means I want to have something different. I want to eliminate some things. Here. So let me collect the ones with the integral. Look at this. I have this part here is exponential ax cos bx. Here I have exponential ax cos bx. When I bring it to this side, this one as a negative. When I collect it to the left hand side, it will be plus. But the coefficient here is 1. Here I have b squared over a squared. That means I can now have 1 plus b squared over a squared, then integral of exponential ax cos bx being equals to, I have here 1 over a exponential ax cos bx plus b over a squared exponential ax sine bx. Sine bx. I have that. Now if I have this one is a coefficient. This I can write this one in another form. This is the same as a squared plus b squared over a squared integral of exponential ax cos bx being equals to 1 over a exponential ax cos bx plus b over a squared exponential ax sine bx. So the next thing I do, both sides I divide by a squared plus b squared over a squared, what I have there, because I want this one to cancel that. Then I come to this side also, I do the same to both. I have divided by a squared plus b squared over a squared. So if I have that, I remain with now the integral of exponential ax cos bx to be equals to, when I bring this one up, a squared will be up, so I'll be having a squared over a squared plus b squared, everything divided by a. So I'll be having in this one, if it works on this, I'll be having a will go with a, so because I'll be now be remaining with a over a squared plus b squared exponential ax cos bx, then plus this one works on that, so I have a square will go with a squared, so I remain with plus b over a squared plus b squared exponential ax cos bx. So this one is the integration of exponential ax cos bx. I end up with a over a squared plus b squared exponential ax cos bx plus b over a squared plus b squared exponential ax cos bx. So follow that. So the first thing you need to know is that you must include the signs. If you look at what I have here, this sign here is u dv minus integral of v du. So when I come to this, I must indicate the signs. That is why I'm saying this DI method is just an improvised of the formula. So get that. When you follow that, you will realize this method is very easy and will help you solve that a lot. So this one is the last solution of the integral of exponential ax cos bx, which gives us a over a squared plus b squared exponential ax cos bx plus b over a squared plus b squared exponential, sorry, here we have sine bx. So we have a over a squared plus b squared exponential ax cos bx plus b over a squared plus b squared exponential ax sine bx. So get that. I hope you have enjoyed the lesson, and still more videos are coming.